Chapter 2, Lesson 5, Adding and Subtracting One-Step Equations. We're going to do some visual work here, and so you can kind of see visually how we're solving this problem. The problem is 17 plus m equals 21. So I'm going to make m be a box, and every number is going to be a dot. So for every one, there's one dot. So I'll have, and just so I don't have a million dots all over the place, every 10 dots, I'll put a 10 with over a dot. The key to equations is keeping it balanced. We have to be fair. What you do to one side, you have to do to the other. So I want you to think of it as having a wall going down the equal sign and going down the balance scale. So since we have an m, we're going to put a box there, and then we're going to put a 10 dot there and 7 more dots on the left side, and then on the right side we're going to put 2 10s and a 1. So the box equals m, and we have 17 on the left and then 21 on the right. We want to get rid of stuff. Our goal is to get the box, the variable, by itself. So if we remove something from one side, we have to remove it to the other, from the other. Remember, keeping our equation balanced. So I'm going to take a 10 off from this side, from the left. That means I got to take a 10 from the right. I'm going to take 7 dots away from the left, which means I'm going to need to take 7 away from the right, which if I do that, I'll take the 10 off, add 3 more dots for what I had left over. And I have a box all by itself now, which is what I'm trying to get, the variable all by itself. And then on the right, I have 4 dots. So there's my equation. Doing that algebraically, remember we're trying to get the variable by itself. So what's the variable in this case? M. I would like you to highlight the variable so you can remember that's what we're trying to get by itself. Subtract 17 from both sides, keeping our equation balanced. If you do something that wasn't there before, you have to do it to both sides. The positive 17 and the negative 17 zero out. I'd like you to circle that to show that it's zeroing out. And we'll have m left over on the left side. 21 minus 17 on the right side is 4. So we get the same answer algebraically. M equals 4. If you plug m back in, sorry, tongue twister, you should get the same answer. So if we do 17 plus 4, do we get 21? Yes. That's a way to check your answer and make sure that your answer is reasonable. Here's problem number 2. 15 equals x plus 6. Again, we're going to use a box for the variable and dots for the numbers. We put a line down the equal sign and down the balance scale because that's our fence. If we do something to one side, we have to do it to the other. So we've got 15 dots on the left side. We'll have a box. How many dots should we have on the right side? Hopefully you're thinking or saying 6. Okay. Now our goal is to get the variable, the box, by itself. So that means we need to get rid of those 6 dots. So I start getting rid of dots here. And they're popping. And I had to borrow from the 10, so that's going to leave me 9 dots on the left side. I now have my box all by itself. So we end up with 9 equals the box, or 9 equals x. Now let's solve that algebraically. Where's our variable at? Hopefully you were saying the x. Highlight that. We need to get it by itself. What's over there messing it up? The plus 6. So let's get rid of 6 on both sides, keeping our equation balanced. What's plus 6 and minus 6 do to each other? Give us a big fat 0. Again, circle that to show you that they're canceling out. 15 minus 6 will be 9, not 3. I don't know where that 3 came from. Ignore the 3. And we should get x equals 9. I apologize for that. User error. Would you try this problem on your own? I want to set it up using the balance scale and doing it algebraically. So at this point, pause the video, attempt this problem on your own. When you're ready to see if you did it the same way I did, then go ahead and restart the video. Okay. Lines down the middle. What we do to one side, we have to do to the other. We start with a box, 6 dots. On the right side, we'll have 13 dots. Start getting rid of dots on both sides, keeping our equation balanced. And we now have the box all by itself on the left side. We have 7 dots on the right side, so our answer should be x equals 7. Doing this algebraically, first thing I want you to do is locate the variable. Where is the variable here? It's the x. What's being done to the variable? They're adding 6. We're going to do the opposite. We're going to subtract 6 from both sides. A plus 6 and a minus 6 zero out. I want you to circle them. 13 minus 6 hopefully gives us 7. And we are set. We got the same answer. Okay, a little different with subtraction. So we're going to add a new little piece to the puzzle here. We had a purple dot was a 1. But we have a minus 2. Could we show a minus 2? Well, we're going to do that by saying every negative 1 is going to be an open circle. So on the left side, we'll put a box with 2 open circles. On the right side, we'll put 3 closed circles. Again, our goal is to get the box by itself. So we want to cancel out those 2 negatives, so we're going to add 2 positives. Adding positives and negatives cancel each other out. So positives and negatives kill each other off. And that leaves us the box on the left side and 5 dots on the right side. So x should equal 5. Let's do that algebraically. First thing again, identify your variable. X. What are they doing to x? They're subtracting 2. So if they're subtracting 2, what do? We do the inverse operation, which is add 2 to both sides. Got to keep our equation balanced. We have to be fair. What does a minus 2 and a plus 2 do to each other? They cancel each other out. In other words, we get a big fat 0. Again, I want you to circle those, showing us that they cancel out. We now have x on the left side, and 3 plus 2 is 5. Again, if we plug that back in, it should make sense. 5 minus 2 equals 3. You do need to show your work. I realize that a lot of you will be able to do this in your head. You have to show work. Would you please try number 5 on your own? Okay. If you haven't paused the video, you should have paused it and done this on your own. All right, so let's do our lines down the middle. On the left side, we should have put a box and 5 negative circles. And then on the right side, we'll have 9 positive circles. How do we need to get the box by itself? How do we do that? Since those are negatives, we need to add in positives. If we do it to the left side, we have to do it to the right side. We have to be fair. Okay, the positives and negatives will cancel each other out. And now we have the box all on its own. And then we now have 14 dots on the right side. Doing that algebraically, identify the variable. It's x. What are they doing to x? Subtracting 5. So we do the opposite. We add 5 to both sides, keeping the equation balanced. A minus 5 and a plus 5 cancel each other out, giving us a big fat 0, leaving x, and we get x is equal to 14. It's Variable is all by itself, so we're set. And we are done. So what I'd like you to do now is summarize this lesson. In your own words, how would you describe what to do when adding and subtracting one-step equations? When you're done with that, explain your summary to your parents and then get them to sign it, and you're all set. Thank you. If you have any questions, send them to me on Remind or Edmodo.